And we're still going to use SOHCAHTOA. Oops, I guess I should have something to write with, right? Remember SOHCAHTOA. Okay, so we still want to use that. Remember, if we're looking for angles, we're going to use what? What do we use if we're looking for angles? Inverses. Good. So angles, we're looking for using inverses, right? So we want to still use all that stuff that we've learned, but now we're going to apply it to a story problems. Okay? So there's a couple words in story problems we want to talk about. And the first one is angle. Well, they're called angle of elevation and angle of depression. So basically what it is, it goes from my eyesight out. Okay? So angle of elevation is me looking from my line of sight out and looking up. That's my angle of elevation between the sight line. If I'm looking straight ahead, my sight line looking straight ahead and then going up, that's my angle of elevation. And if I'm looking down, that's the angle of depression, right? Up is elevation, down is depression. Does that make sense? That's those two, basically that's what those two words say. So if we have those in our story problems, this is kind of like, that's what the pictures would look like. So you can see the two pictures here. Here's my angle of elevation and my angle of depression. So that's what the two pictures would look like. And then to complete the triangle, right, I would just drop my lines here, and then I have then I have my right triangles. Okay, and then I'm going to do my right triangle trig, just like what we're talking about. Does that make sense? Okay. So those are the two hard words that we had to talk about. Everything else is pretty straightforward. So it says for each problem, make a drawing. The drawing is super hard. Guess what the drawing is? A right triangle. Okay? So the hard part is deciding what the measure on which side is which. Okay? So we're going to kind of talk about that as we go through it. Write an equation and solve. So this equation is going to be either sine, cosine, tangent, just like what we've been doing. We have to decide if it's sine, cosine, tangent. Okay, so it says Carrie places a 10-foot ladder against the wall. So here's my wall. Here's my ladder. My ladder is 10 feet, right? Can you see up there? Okay. And then here's the ground. Alakai Yatsiri. Okay, if the ladder makes a 65-degree angle level with the level ground, so this is 65 degrees. How far up the wall is the top of the ladder? So here's my wall. It wants to know how far that distance is. Okay, pretty easy, right? So now I have a right triangle. Now I'm just, hopefully, by the way, hopefully my building forms a 90-degree angle with the ground. We're assuming that it does. We're just going to make that assumption, okay? So now I'm going to use which function? Is that sine, cosine, or tangent?
Sine.
Sine, because I have the opposite and I have the hypotenuse, right? So I'm going to say sine of 65 equals x over 10. Cross multiply. And I get x is going to equal 10 sine of 65,
4.2.
which I'm going to put in my calculator. And 4.2, really? Wow. Can I double check? I'm sure you're probably right, but... Oh, okay, there we go. 9.1. I was like, 4.2 seems a little short. 9.1 feet. And remember, it says right here, I just want to point this out here. Do not forget to include units of measure. So it was 9.1 feet. So a story problem, we need to make sure we're putting our measures in there. So 9.1 feet. I was like, I'm pretty sure it's not 4 feet.
Yeah.
Okay, we good? Question: did you divide instead of multiply?
I multiply.
To get 4?
That's because I got cosine.
Oh, okay. Yeah, well, that would make sense. Okay. So our next one, sorry I can't zoom in any closer, especially for you guys in class, because it's a story problem. It takes up a lot of the screen, right? So a flagpole. So here's my flagpole. Whew, flagpole, right? Casts a shadow that's 15 feet long. So my shadow is on the ground and it's 15 feet long. The angle of elevation of the sun. So angle of elevation is always going up. So that's this one. At that time of day is 40 degrees. How tall is the flagpole? So which one am I going to use? Which trig function?
Opposite over adjacent.
What is that?
Tangent.
Tangent, great. So tangent of 40 equals x over 15, right? Cross multiply, and I get, what do I get? X equals 15 tangent of 40, which is approximately equal to
.6.
12.6 feet. Woo! Questions? Okay, Alakai. Okay, a ramp used for loading dock equipment from a dock to a ramp is used for loading equipment from a dock to a ship. The ramp is 10 feet long and the ship is 6 feet higher than the dock. So it's here, right? 6 feet here. And my ramp is 10 feet long. What is the angle of elevation of the ramp? So what is this distance here? Or not distance, what's that angle? Right, so which function am I going to use?
Opposite over hypotenuse.
Which is?
Tangent. Sine.
Sine, good. So sine of x is going to equal 6 over 10. So what do I do now?
Inverse.
Good, right. So I'm going to do inverse sine because I don't want sine of x, I just want x. So I get x is going to equal sine inverse of 6 over 10, which is approximately equal to
37.
For this purposes, we're going to leave one decimal. So 36.9 degrees. Okay? So on all this, we're just rounding to one decimal. Okay? And that labeling it is putting the degree sign. So 36.9 degrees. Okay? How do we feel about that, you guys? Not too bad? Feel okay? All right. So what I want you to do is go to the second page. I'm going to put that up there for you guys in just a second. And there's 4 story problems. I guess we're going to, because I want you guys to be able to read them, we're just going to do them 2 at a time. So do A and B first, please. And go. A and B. So it says in Southern California, there's a 6-mile section of road. So I've got my road right here. Okay, that increases 2,500 feet. Oops, I can't even write it right. See if I can write it right this time. 2,500 feet, okay? And it's 6 miles. So I need to write the 6 miles in feet. So I take 6 and I multiply by 5,280, right? And I got 31,680 feet. okay? So that's how long that road is. And then they want me to find the angle of elevation, and I just called that theta, okay? So let me fix that a little bit because it looks kind of bad. Theta. Okay, so I said sine, and you could have used x, that's fine, it doesn't matter what you used, right? Sine of theta equals 2,500 over 31,680. And I don't want sine of theta, I just want theta, so I'm going to do sine inverse. And so I'm going to get theta is going to equal sine inverse of 2,500 over 31,680. Is that what you got, Ketlin? Did you do that? No?
No,
What did you do wrong?
I don't know, I was a little confused with this one.
Because of you had to, okay. So you should get 4.5 degrees. But notice I just do exactly the same thing, right? I just convert it and then put the road there for you.
Yeah.
Okay. Just so you know, on your homework, you don't have any that you have to convert, okay? But just be aware of the fact that they need to be in the same, unit. So I can't do one in miles and one in feet and get the correct answer, okay? So here, number B says a hot air balloon is 100 feet straight above where it's planning to land. So I did 100 feet here. Okay, and Sarah is driving to meet the balloon when it lands. So Sarah is somewhere out here. Here's Sarah, right? The angle of elevation, so she's looking up at the balloon. Oh, angle of elevation is 35 degrees. How far away is Sarah from the place on the ground where the balloon will land? So how far away is she from here, right? So that's going to be tangent of 35. Notice how I just did each piece of the story problem at a time, right? I didn't read the whole thing and do it. I drew the picture as I was going along. I did each piece and I drew it on the picture. Okay, I think that kind of helps sometimes too. So tangent of 35 equals 100 over x, cross multiply, and I'm going to get x tangent of 35 equals 100. Divide by tangent of 35. And x is approximately going to be equal to, did you get this one, Kellen?
Yeah,
What'd you get?
142.9.
0.8. Because I think it's 8.2. Right, yeah. Okay, so now let's go ahead and have you do problems C and D. I'll give you a few minutes to do those. Okay, so the C says, Michelle is 60 feet away from a building. So here's my building. Here's Michelle, 60 feet away. The angle of elevation to the top of the building is 41 degrees. How tall is the building? So there's that. So this is tangent equals x over 60. Cross multiply. I'm going to get x equals 60 tangent of 41, which is approximately equal to 52.2 feet. Beautiful, okay? And then the last one, D, an airplane is descending as it approaches the airport. So it's descending as it approaches the airport. The angle of depression from the airplane to the ground is 7 degrees. The plane is 2,000 feet above the ground. What is the distance from the plane to the airport? So this distance here, how far is the plane from the airport? Yeah, I think they're asking for that. Usually they'll let you know the horizontal distance or the diagonal distance. It doesn't say. So I'm just going to say how long is it going to take. That's the distance there. So this is sine of 7 equals 2,000 over x. Cross multiply. X sine of 7 equals 2,000. Divide by sine of 7, and x is approximately equal to 16,411 feet. Woo! Okay? Is that not too bad? You guys, if you can write out, if you can draw the picture, it's usually not too hard to do, right?
Yeah.
It's just sometimes drawing the picture is a little hard. The nice thing about the Canvas, again, I have it's the pull down menu, so the answers are on there. So if you don't find the answer on there, you did something wrong, probably on your drawing, right?
Yeah.
So I like that because that way it kind of gives you an idea if you've got it right or wrong. Okay? So I think there's